We've looked at fundamental theorem of calculus, and part 2 of it says that if you evaluate an integral from a to b, that ends up being equal to the antiderivative at b minus the antiderivative at a, provided that the function's continuous on the interval from a to b. So what we're going to look at today is kind of a twist on that. If we were to take and manipulate this equation by adding f of a over to the other side, it would give us this equation here. And we're going to, and this kind of gets used on a few of the problems that pop up. And what this is saying, if you have this, is that the value of f of b, which is kind of like our ending value, is equivalent to f of a, which is like our starting value, plus our change. This is the integral would give us the net change. And so when you're using kind of this twist on the fundamental theorem of calculus, f of b is your ending amount. It would be your start equal to your starting amount plus the change that the integral would give you for that function. Let's look at a problem where we might use something like this. It says here that f of 2 equals 9. The derivative of f is continuous, and the integral from 2 to 5 of the derivative of f is equal to 16. What's the value of f of 5? Well, we know if we have the integral from 2 to 5 of this derivative of this, of f, we should know what that was equal to using fundamental theorem of calculus. So what we'd want to do is figure out what's the antiderivative of the derivative of f prime of x. Well, antiderivative of f prime would just be the function itself. So this should be equal to f of x evaluated at both 5 and 2, which would end up being equal to f of 5 minus f of 2. If we put that little twist on this that we talked about, what we're going to end up getting then is that f of 5, our ending value, should be equal to, if we add f of 2 over to the other side, f of 2 plus our change here. And now we should be able to solve this because we can plug in the values that we know these are equal to. This integral here is equal to 16, so we can plug in that. That's our change from 2 to 5. Our starting value was 9. That's what f of 2 was, so we can plug that in there. So if our starting value was 9 and our change from 2 to 5 was 16, that means f of 5, our ending value, should end up being then 25.